Everyone, so today we are going to solve a very famous LeetCode problem, node with the highest edge score. So let's first read the problem statement, and then we will move forward to the solution. So what is the problem statement? You are given a directed graph with n nodes labeled from 0 to n minus 1, where each node has exactly one outgoing edge. The graph is represented by a given zero index integer array edge of length n, where edges of I indicates that there is a directed edge from the node I to edges of I. The edge score of a node I is defined as sum of labels of all the nodes given an edge pointing to I. Return the node with the highest edge score. If multiple nodes have the same edge score, return the node with the smallest indices. So let me explain you the problem statement. So basically we are given a graph in the form of the array. So where here how we can form the graph. So basically the problem description is saying, let me write the indices number first and then I will explain. I think it is better to move this on the board. So we will move. Let me connect the board first. So uh, let me move this test case to the board and then I will explain. So wait a minute, I will write the indices 0, 1, 2, 3, 4, 5, 6, 7. So problem description is saying that there is a directed edge from the indices to the specified value of that indices. So we will first form a graph. So as we say, see, there is a edge from 0 to 1. 0 to 1 there is a edge. From 1 to 0 there is a edge. From 1 to 0 there is a edge. From 2 to 0 there is a edge. 2 to 0 there is a edge. From 3 to 0. From 3 to 0 there is edge. From 4 to 0 there is edge. From 5 to 7 there is edge. So from 5 to 7 there is a edge. From 6 to 7 there is edge. From 7 to 5 there is a edge. From 7 to uh, from 7 to 5 there is a edge. So basically this is the problem description saying, and we have to tell the node with the maximum edge score. So the score is defined as the maximum number of node pointing to the current node. There like maximum of the maximum sum of the nodes value which are pointing to the current node. So what is the meaning of this? For this value, 0 is pointing to this, so the sum of the nodes pointing to this one is 0. Here no one is pointing to 3, so it is still 0. Let me select this. This is still 0. No one is pointing to 2. This also for this 0, for this 0. But for 0, 1 is pointing to 0, 4 and 2, 3. All of these are pointing to 0. So the sum of all of these will be the answer for this. So 4, 2, 6, 6, 3, 9, 9, 1, 10. So 10 will be the answer. Edge score for 0. What will be for here? For 6, no one is pointing. For 5, 7 is pointing. And for 7, 6 and 5 both are pointing. So as we can see, this 7 has the maximum edge score. So this will become our answer 7. So as this 7 will become answer, so 7 is given here. So let's move forward to the solution. Basically, as you can see, there are two components. So this is add-on. So a graph can be disconnected. This is the major difference between a tree and graph. The graph can be disconnected and tree cannot be. So by the way, let's move to the solution and see how can we solve this together. So I have pre-written the solution here. So let me explain you. So I have first declare a long array. So this is of long, basically long for a reason, so that the sum does not exceed any of the integer bound limits. So this is basically for like it does not exceed the limit. You can take it as in 2. So what we are doing here, we are calculating the number of incoming edges towards the ith node. So basically, let me explain you through. So basically, I have this array initializing all the elements with 0. So what we are doing here, as we know that I this edge of I value, for this edge of ith value, I is coming inside towards it. This means this for the example, like for this 7 who is coming to it, is indices value 6. So what we are doing, we are just putting edges of I. So this we are putting this 7 here. So 7, basically for 7 the I will be added to this. So this will calculate the all the sum of the all incoming edges toward it. So let me explain you again. I think that will be better. So what the solution is, we have this empty array. So for zeroth node, what we are doing, so or the this is the array. So for oneth node, we are doing what we are doing for oneth node. So in this node, if we put edge of I, so edge of I is 1. So here will be edge of I, like here we are pointing right now, and then we are adding this I to it. So this I currently is 0. So 0 will be added here. So the sum of this will be 0, and then we will move to this 0. So then this 0, this value 0 will come here, and this will point to this block, and we will add the current value which is 1. So 1 will be added here. So this means like for 0, 1 is pointing towards, and this, I think you are getting idea of my solution. So this is how we will calculate all the incoming edges score for a current node, and then we will just initialize a simple variable, uh, max ans index, which will initialize as 0, assuming that the minimum index 0 with the highest score. And then what will we will try to see which will become our answer. So what we are doing, we are comparing the ith score with this maximum answer I score. If we get any of the score greater than this we have previous stored uh, node, then we will update the node, and later we will return the node. So this will be our answer. And what will be the time complexity? So the time complexity for calculating the node and getting the answer is n plus n, basically O of n for this and 1 for this, and this is the linear time. So we will consider it as O of n. And for space complexity, we are only taking an array that is O of n space. So the time and space complexity of O of n. uh, thank you for watching my video.